The topic is containerizing multi-stage Docker build and Docker Compose for full stack React Express JavaScript application, that is Resume Matcher. This full stack application was built by me a few months ago. Now let's containerize it. I will explain you the Dockerfile, the Docker Compose and the Docker ignore of this containerized application, and we will run this container to see how it works. So let's understand the Dockerfile. We must know that the purpose of Dockerfile is to create a blueprint of our application. The Dockerfile consists of syntax and it creates application in a container. You create a Dockerfile, you build it, and it becomes an image. When you run that image, it becomes a container, which is an app in itself. So your application would become a container, and that container would be a functioning app of yours. Dockerfile is something where you give steps and you give dependencies, builds, runtime environment, all these steps in a Dockerfile, which helps it in building your application in a container. So Dockerfile acts as a blueprint for your containerized application. So now for my application, that is Resume Matcher, let's understand its multi-stage Docker build steps. My application is a multi-stage build. The purpose for multi-stage was to balance the small image size with the compatibility for the native modules, which were like Sharp. That depends on library VIPS and glibc. So that was about the Dockerfile. Now let's understand what is the purpose of multi-stage builds. The importance of multi-stage is to break down Dockerfile into stages, and final stage is the runtime environment. So we take the artifacts from the build stage and we utilize those artifacts to the last stage or the final stage, where we create a runtime environment from those build artifacts. So the image is lean and lightweight. Stage 1 is the build stage, where we build from Node.20 Alpine as builder. As builder is the reference. Builder is the reference for our Node.20 Alpine base image. Workdir is the working directory, that is /app. This uses Node.20.js 20 Alpine, which is a lightweight base image, and it sets /app as the working directory. So there exist multiple technical stacks, which includes Python, Flask, Node.js or React.js, etc. So mine is a Node.js application, so it is a JavaScript. So my Dockerfile build or multi-stage build will be based on those JS commands or those syntaxes. Now run apk add no cache / that is the current folder, followed by Python 3 until fftw-dev, followed by build base. So this command is used to install build tools and libraries that are needed to compile native modules, that is Sharp, for my application. So Python 3 make G++ are compilation tools. VIPS-dev, FFTW-dev is a dependencies for libvips that is used by Sharp of my application. Build base. This is the meta package with essential compilers and libraries. Basically, run apk add is to install build tools and libraries and native modules for my application. Copy package star.json followed by /. Run npm ci. This command is for copying the dependencies manifest. Run package.json contains the dependency manifest, so it copies it into the current folder. npm-ci is for clean, reproducible install, which is better than npm install. Copy ... followed by run npm run build. This is to copy the entire steps which we did from the from statement until these steps. So it copies all of this into the current, and that run command builds the project. So that was about the build stage. So this build stage gives us essential libraries and build tools which would help us in the later stage, that is the later stage of or the final stage, to create a runtime environment from those build stage artifacts. Stage 2, which is runtime, from Node.20 Slim workdir, that is /app. This switches to Node.js 20 Slim, which is a Debian based. Debian Slim is chosen because it uses glibc, which ensures that sharp works correctly at runtime. It is based on the dependencies and working of my application, so Debian Slim works better in my runtime, so it is used. And working directory is /app, and multiple copy statements until package.json. This copies only the build output and necessary files from the build stage. So only necessaries, artifacts or build output from the build stage is copied. This keeps the runtime image lean, no redundant dependencies that would increase the image size and make it heavy. So it only uses necessary files from the build stage to create a runtime environment. Run npm-ci only production. This installs only production dependencies, which ensures sharp is rebuilt correctly against glibc, which is simply installing only the production dependencies for lean image or lightweight image. Expose 3000 cmd node server.js. This exposes port 3000 for the application, which runs server as an entry point. It simply means that the application would run on port 3000. Alpine for building, that is lightweight, fast builds. Debian Slim for the runtime. This is for the compatibility for the sharp dependency. Multi-stage build. The purpose of multi-stage was to keep the final image small by excluding build tools and developer dependencies. npm-ci. This is for reproducible installs. This avoids dependency drift. In short, this Dockerfile compiles of sharp in Alpine with all build tools, then runs the application in Debian Slim for glibc compatibility, which ensures a small production-ready image that works reliably with native modules. Now let's understand Docker-ignore or Docker-ignore. Docker-ignore file tells the Docker which file and directories to exclude from the build context when sending data to the Docker daemon. Docker-ignore helps to keep the images smaller, builds faster, and avoids leaking sensitive files. So we have ignored node_modules. This excludes node modules because dependencies are installed inside the container, that is npm-ci, not copied from my local machine. This prevents from bloating the image with host specific modules. Node modules are ignored because it includes host specific modules, which is required to run in a local machine or my system. We are containerizing the application, so we don't need those dependencies that are required for running in the local machine. Prevents from bloating the image or increasing the image size. TMP, in short, distribution and temporary. This excludes compiled or build files from the distribution and temporary files. This excludes compiled or build files, that is distribution and temporary files. Ensures only source code is copied and container builds fresh output. .env excludes env file, environment variable files, which contains secrets of database passwords and API keys. This is to prevent accidental leakage into the image layers. So the environment variable has sensitive data of the API keys and database password. To prevent it from accidentally leaking into the image layers, we have ignored it in the .docker ignore. Logs, that is .log, npm, yarn, debug, yarn error. This excludes log files generated during the development. This keeps the image clean and avoids unnecessary clutter. .git ignore, .git. This excludes Git repository metadata and ignores rules. These repository metadata and ignore rules are not needed inside the container. Operating system files, that is .ts, store thumbs.db. This excludes operating system specific chunk files, Mac OS, that is .ds store, Windows thumbs.db, IDE or editor configurations, that is .vscode.idea. This excludes editor setting or configurations, VS Code, prints. This keeps the container environment independent of developers' IDE. Test, docs, coverage. This excludes test files, documentation, and coverage report. These are not needed in the production builds. Finally, deployment specific, that is .vercel. This excludes development. This excludes deployment metadata, which is like a vercel configuration. This keeps the container focused on the runtime code only. Docker ignore step is important because it helps in keeping the smaller build context, cleaner images, and better security. Now Docker compose. We know that Dockerfile creates an image and runs a container. When there are multiple containers and all of those containers depends on each other, instead of manually starting each container by complex Docker commands, we create a Docker compose file. That Docker compose file contains commands which is composed of a single command. It turns on or starts all those containers which communicates with itself, so we don't have to start each container one by one. So our Docker compose file consists of 3 service stack, that is 3 containers, Node.js application, which is web, a Postgres database, DB, and Nginx reverse proxy, naming Nginx. I have explained the concept of multi-stage Docker build and Docker compose in my previous video. You can watch those videos so you can have understanding of concept, Docker compose, and multi-stage build, which means our app containerized application will be running on 3 containers. First, that is web, second DB, and third Nginx. So these services will be defined in the Docker compose file. So first is web, build space dot. This builds from the local Dockerfile. Maps port 3000 on the host to the containers port 3000. env file loads environment variable from .env, which includes API keys and database passwords. Networks AppNet, which means connected to AppNet network for internal communication. Health checks. This calls /health endpoint every 30 seconds. If it fails 3 times, container is marked unhealthy. That was about web as a service in a Docker compose file. Now DB service stack in a Docker compose file. It uses Postgres 15 Alpine, that is lightweight, as an base image. env file loads the credentials or configuration from .env. Volumes, persistent data in a named volume, DB data. We need something to store our data. So DB data is the named volume where the database data would be stored, and the actual path is /var/lib/postgresql/data. It stores the persistent data. Networks, that is AppNet, which means it is connected to the AppNet network. Health checks. This runs pg underscore is ready, which means Postgres is ready to verify database is accepting connections or not. Also has AppNet as a network, so this AppNet would help in communication between these 3 containers. Now Nginx as a service stack in a compose file. This uses Nginx Alpine as a base image and maps port 80 on host and containers port 80. This mounts a custom Nginx configuration, that is default.config, into containers read-only, depends on web. This ensures that app is up before proxy starts. That means Nginx as a service depends on web as a service stack, which I explained before. So when the web as a service container is up and running and it passes health checks, then this Nginx proxy service starts. So it depends on that web. Connected, that is AppNet. Networks, that is AppNet, which means it is connected to AppNet as a network. Health checks, this pings / every 30 seconds, which means it pings the root, that is localhost, every 30 seconds. Volumes and networks. Volumes, that is DB data. Networks, that is AppNet. DB data, this is the named volume for persistent Postgres storage. AppNet, this is a custom bridge network, so containers can talk to each other by service name, web, DB, Nginx. So AppNet is a network bridge that helps containers talk to each other by their service name, which is like the web, DB, and the Nginx. In short, web runs Node.js app, DB handles persistence, that is DB data. Nginx serves as a reverse proxy or the load balancer. Health checks ensure services are actually ready before others depend on them. Named volume keeps DB data safe across container restarts. Custom network isolates application stack from other containers. This compose setup gives us a production style mini stack, that is like a Node.js application behind Nginx backed by Postgres, all wired together with health checks and persistent storage. So that was about the explanation of this Dockerfile, Dockerignore and Docker Compose. Now let's run this application to see if it is even working or not. First, you must know that after you create a Docker Compose file with Dockerfile and Dockerignore, the first command you should run is docker compose up build. So that would build and then run. So I have already built and run my container before. So I'll just do docker compose up to see how it works. I switched into my directory. Now you can see like DB, Nginx, web. That are the three service stack or the containers that are running and that are interconnected or that communicates with each other with AppNet network bridge. Now let's confirm it by going into the localhost 3000 as it is serving and running on port 3000. As you can see, it is healthy and running on port 3000. Let's confirm it by adding a resume into it. As you can see, results are also visible, which means the application is up and running perfectly fine. As you can see, this is the results of my resume. Now let's check and see the logs. As you can see in the logs as well, it is up and running perfectly fine. When I do Control C, it stops this. Now it's stopped. Let's check again. Now it's not running. We can see in our Docker desktop application, our container is stopped. So that is it for the video today. I hope the topic was simple and insightful. Make sure to like, share and subscribe. Thanks. Have a great day. Bye.